In this video, we're going to take a look at XXE based vulnerabilities, which means XML external entities. These type of exploits are associated with being able to parse XML data in a way that allows you to leak information from the server primarily, is what they do. So the way I'm going to demonstrate this is through Portswigger's labs. They have a number of different labs that are available for XXE, and they're very good for being able to practice the sort of foundations of these skills and to be able to sort of demonstrate all the different scenarios that you may see XXE become available in. So I'm going to approach these from the perspective of showing you how you can identify these sorts of vulnerabilities and then how you can exploit them. And then we'll talk a little bit about how we can fix them and make sure that these problems aren't present in our software. So before I start, I'm going to give you a little bit of an introduction towards the tools that we're going to be using for this. There's one tool primarily, which is also made by Portswigger. It's known as the Burp Suite. There's a community edition and a professional edition. I'm utilizing the community edition. Essentially, this will allow us to capture traffic between ourselves and the web page. What that allows us to do is that every time we send a request to this web page, we're able to see what data is sent between us, which will allow us to sort of manipulate the data and inject things into it, which will allow us to be able to exploit these XXE-based vulnerabilities easier. So we're going to go through a few different scenarios. The first one that we're going to take a look at is exploiting XXE using external entities to retrieve files. The idea of this sort of problem is that when we use XML data, if a user is sending XML data to the server and they have full control over that XML data, what they can do is they can write in these things called external entities. And what external entities can do is they can reference files anywhere, really. So they can mainly reference files that are actually on the server itself. And through this, they're able to get back data from the server using this XML request. So this is something that obviously we don't want to happen. And this one, we're going to demonstrate how to get the password file from a Linux server, essentially. So what we'll do is go ahead and access the lab here. Just to note, as we're getting on here, in order to access these labs, you will need an account. It's a free account to register, so you can go ahead and register one for that. You'll see this essentially has just like a shop, and we can go into this shop and we can view details. And we go to view details, we can check the stock of items. And when we do that, it will tell us how many units are in stock in the specific store that we look at. So obviously from here, we can tell that there's some sort of query happening in the background. And from that, we know that we're basically going to have to pass this information from our client to the server. Anytime that we're passing information from the client to the server, there's a potential to be able to inject malicious content into the actual web application itself. So to be able to see this in action, we're going to launch up Burp Suite, and we're going to do that ourselves here. So let me just go ahead and reset here. The way that this sets up, if you've never used Burp Suite before, I'm on Firefox. In this case, it's my preferred browser. If I go into Options, I can type in Proxy. And inside of the proxy settings here, we just have to set up a proxy configuration to the proxy that's set up on Burp Suite. So you'll be able to see that in general here. So you'll see proxy service started on 127.0.0.1, port 8080. We just put that information into here as well. And I just match it through everything and press OK. Once that's done, we'll now be able to intercept data. So we'll specifically go into our proxy section here and turn on the intercept. Now we'll be intercepting the web traffic between us and the web pages that we're accessing. So as discussed, we can come in here and we can check stock. When I click check stock, you'll see it will sort of pause. And inside of here, Burp Suite will show me the data that's being sent to the server here. So I can forward each packet and go through them one at a time and just see what kind of data is being sent through. So let's go ahead and switch it to say London, and we'll say check stock. And as you can see, it shows us the general packets that are flowing through. Now, for some reason, some of them work, some of them don't. So you sort of have to play around with it a little bit. In some instances, you might get these certification invalid things. Essentially, when you work with Burp Suite, it injects a certification between you and the server. So it will tell you that the certificate is invalid. You can just accept that and continue. So we'll go ahead and try this one here, for instance, and see if this one will work. So I'm going to turn the interceptor on, and let's say check stock. As you can see here, you can see the general payload that's being sent. You can see that it's sending this XML data to the server. And inside of this XML data, we have the product ID and the store ID. What I'm going to do is I'm going to go to Action, and I'm going to send this to the repeater. The repeater essentially allows us to modify the content of the query itself and be able to send it back to the server so that we can try different things with it. So with that being done, I'll go ahead and turn off the interception for the proxy, and let's head over to the repeater. So you see, here's the general format of our XML. If we want to do an external entity attack, there's two main things that we're going to have to do here. The first is up here, we're going to have to define our external entity that we're trying to access. So we'll do this as follows. Say doc type. I'm going to call this foo, and we'll go ahead and do this. It'll be an entity. I'm going to call the entity XXE, and we're going to get a system file, and that system file will be the file at the location etc password. So this would be the general structure of our external entity. What we do is we essentially define that we're creating an entity, and we give the entity some sort of name. And this name can be really anything that you want. I just pick XXE as this example. And we say what the entity is going to be. In this case, it's going to be a system file. And that system file is going to be the file that is located at this path, the etc/password path. Now all we have to do is just change one of these values to that external entity. And what will happen is it will attempt to access that external entity, and it will return us back the results. And the results in this case are going to be the contents of the password file. So the way that we access this is we put an ampersand, and then we put XXE, and then a semicolon. So now I can send this query, and you'll see we'll get a response back here on the left-hand side. And as you can see, it says invalid product ID, and then it leaks all of the information that is contained inside of that password file. This is the idea of what an XXE exploit is going to look like. Essentially, it's going to attempt to access that product ID, and it's going to be invalid. And when it sends back that invalid error, it's going to in turn send back the contents of that external entity we attempted to access. And that would be, in this case, the contents of the etc/password file, which, as you can see, is all the different users that are on the system. So you can see with this, we're able to access really any sort of file that's on the system, which is very dangerous, right? The information disclosure from this is huge. If we are able to access the shadow file of a Linux system, for instance, that would give us all the hashed passwords towards which we can then do an offline password attack, and then potentially be able to exploit the system and gain unauthorized access. So like I mentioned before, this is really just one way to be able to do the XXE-based attacks. We'll take a look at a few others as well. So with this problem, we've now pretty much successfully solved it. So that teaches us everything about the external entities from that perspective. One additional thing we can do with XXE is we can use it to perform SSRF attacks. An SSRF attack is essentially the ability to be able to send a query from someone who isn't us. So as an example, there's a server running on here that has some metadata, and there's potentially some sensitive data inside of there. This IP would typically only be accessible from the server itself. So us as a client wouldn't be able to access that. However, if we use XXE, we're able to make the request look like it's coming from the server, which means that we can in turn access things that we shouldn't be able to access typically. So to show this, it's a very similar type of idea to the previous lab. So we'll go ahead and access this. Sorry, I'm going to have to turn back on the interceptor here. Get this going. So we'll turn this back on. Let's go ahead and access here. Sorry, okay. I think we'll just have to disable the proxy and re-enable it. Sometimes this will happen. I think it's because the actual session will expire. So sometimes we have to go back in and just or disable and re-enable the proxy. So go and do that. Let's try to access this page. Okay, great. So now we can access the lab. And then once that's done, I'll go ahead and set up our proxy again. And then we'll come back into here and turn our interceptor on. And again, we'll do something very similar to before. We're going to go ahead and enter into the item, right? And then once we're inside of here, again, we can check stock. So we'll go ahead and check the stock of the London store, for instance. And we'll see if this one gives us, yeah, this one gives us an XML structured format as well, right? So we're sending an XML request to the server. Again, I'm going to take this, I'm going to place it inside of my repeater. And we're going to go ahead and modify this XML, but we're going to do it in a slightly different way compared to before. So let's just turn off the interceptor here. And what I'm going to do here is I'm going to use it to do an SSRF-based attack. So I'm going to, instead of accessing a system file, we're going to access an actual URL. And the way that we do this is relatively similar. So we'll have a similar type of setup. We'll have our doc type. I'll call it foo. And then we'll do our entity. We'll call it XXE. We'll say system. And instead of doing a file request, we'll do a URL request here. So we'll do 162 or 169.254.169.254. 254. I believe that that's the IP. And then we just have to close off the brackets. And this would be what we're going for. Now, again, we want to put this into a piece of the actual XML itself. So we go XXE here. Again, remember to end it with a semicolon. Remember to start it with an ampersand. And that's the general format. Again, very similar to the previous one. However, instead of doing a file, we're doing a URL this time. And you'll see the general process and flow of this is slightly different. So now when I send my request, you'll see in the response, we get unvalid product ID latest. This tells us that the next sub URL here is latest. So what I can do is I can place this latest at the end and then query again. And when I do this, you'll see once this sends through, it says metadata now. So then the next path part is metadata. And this will just slowly expose to us the location of the secure data that we're looking for. So again, we're just going to keep on concatenating what is given to us as the invalid product ID. And essentially all we're doing is just building up the actual URL based on the results of the query, right? And eventually, once we get to security credentials, we're going to put in admin. And what we're going to get is the actual admin credentials. So you'll see here, we get all the information for the admin. We get their token, we get the access key ID, the secret access key, the expiry date, the type of hashing algorithms that's used for this. So this gives us a ton of information. Again, this is a very devastating vulnerability to have on your system. If someone is able to exploit something like this, they're going to be able to get your admin credentials, which is very bad, obviously. So again, the idea behind this is that we can make queries to web pages that we wouldn't necessarily be able to do normally. And one thing that we can do with that is we can slowly build up a URL to some sensitive data using the responses back from the XXE. In general, the response that you're going to get back is going to give you information about either the page that gets visited or the URL pieces that you need to piece together to get to the page that you're looking for. Regardless, eventually, if you continue to query different URLs, you could potentially expose data. So this is another thing that we're able to do here. I believe this sort of thing could also be used to maybe query from the system perspective to another website to try to authenticate against it. However, I haven't really tried something like that. This is the typical use that I've seen for this type of vulnerability. So that gives us the idea behind this lab here. What we'll take a look at next is how we can actually exploit this through an image file upload. This is a rather interesting one because it's not necessarily through the request, it's actually through SVG images. Now, if you don't know anything about SVG images are essentially vector graphics. And inside of vector graphics, we're able to set up sort of length and width and information about the actual vector itself. And that is in turn done using XML. So because of that, we can actually manipulate the XML in a very similar way to any other XML file that we've looked at so far. So let's go ahead and access this lab and we'll take a look at that. I'm just going to flip over my proxy here. We'll go back into the lab. So essentially the idea here is that we have a blog. And inside of this blog, we're able to go into posts and we're able to leave comments. And inside of the comments, you'll notice that there's this avatar that we're allowed to put in some sort of picture for ourselves. Now, the idea is that inside of that picture, we can upload an SVG file and that could get interpreted as XML and in turn reveal information about the server. It'll actually reveal it inside of the image itself, which is quite interesting. So I'm going to show you what the XML looks like for this. Essentially, to understand this, you have to have a bit of an understanding about SVG files in general. So the actual XML pieces are going to work with like the XML version. It's going to display the general information about the standard that we're utilizing. And then what we're going to do is we're going to define our external entity like we did before. And in this case, we're targeting etc/hostname. That'll be the file that we're actually targeting. And then what we do is we set up the SVG width and height, so the width and height of the image itself. And then we give it sort of like the standards that it's using for its formatting and such. And then we say that we're going to print out some font. And the font is going to be size 16. Here's the X and Y coordinates of it. And the text that we're going to put into it is this external entity. So what this does in turn is it prints out the result of the external entity query to text in the image. So it'll create a very interesting sort of effect that I'll show you here. So I'm going to go ahead and type in a comment. I'll just say test. And let's go ahead and browse for a file here. So I put it into here, and it's test.svg. And then we can go ahead and post our comment. We have to actually put it in an email, so we'll say ada.com, and let's post our comment. You'll see it will load, and it will say thank you for your comment. Then when we go back, we can head into the comments, and you can see that my image there has some text inside of it. Now, to get to this, we sort of have to be a little bit creative. The best way that I found to do this is just through the source browser here. If I hover over it, it will show me the image. I can also navigate to that sub URL to get to the image. But as you can see, it wrote the results of the external entity query into the image itself. So you can see that we can be very creative with these types of attacks. We don't necessarily just have to like brute force XML data or anything like that. We can use SVGs as well. So there's a lot of creativity that you can do with these sort of XXE based attacks. Now there's one final type of attack that I want to talk about, and that's XInclude. Now the idea behind XInclude is essentially that when we have XML based data, we don't necessarily control the whole XML document. We might only control a certain input of it. So in those sort of instances, we have to be more creative about what we do because we can't just inject our payload anywhere. What we can do in these cases is using XInclude. And essentially, XInclude is basically going to concatenate the XML together with other XML that we provide. And through that, we can provide a similar payload to what we did in the first two examples. And that in turn will execute and give us a result that will allow us to do an XXE based attack. So let's go ahead and take a look at how this is done. So this is a very similar type of situation to what we previously had. Let me go ahead and set up our proxy here. And let's turn on our intercept. So again, we can check the stock. And what you'll see here that's relatively different is that when we actually check the stock, it's going to post the product ID rather than giving us the XML for it. Seems like this one doesn't seem to be working. Let's just go to a different one here. Let's try this one out for size. So we'll accept the risk here. We'll just forward those through. All right, so let's check the stock here. Let's try this one out. Let's forward these ones through. Oh, this one seems to be having problems. Let's try it again here. Here we go. So yeah, it might take a few attempts, but eventually you'll get one that works here. This one, you can see that it posts the product ID and the store ID. So what you essentially have to do is you have to inject into the product ID or inject into the store ID. This is a very typical sort of situation. You won't usually be given the whole XML document. So to be able to do this, we just have to utilize the XInclude portion. So we'll go ahead and place this into the repeater like we did before. And let me show you how this can be done. So in params here, I can adjust the value of each parameter. So I'm going to adjust the product ID. And what I'll do here is I'm going to set up the following. XMLNS. So this is essentially us just declaring the actual format of the XML document that we're going to be using. You'll notice that anything that sort of references w3.org is basically just sort of like the templated, like here's what an XML file is going to be defined as. It just sort of tells the XML parser how to parse our file. So we can have this portion, let's do backslash 2001, backslash x include. So this tells us that we're going to be using an x include. And the x include that we're going to be using, xi, is going to be defined as include, include parse equals text, href equals file, so that's backslash etc password. And then we'll close off the external entity. So what this does is essentially we have our x include, right? And we define the format of the x include, and then we discuss what we're actually doing with it. So we want to include a parse that's equal to text, and then we give it a reference to where the text is actually located. When we do this, we should be able to send this, and assuming I've done everything right here, we get a response back that is very similar to before, where we get the whole output of the shadow or the password file. So you can see how this generally works, right? The first portion here is us telling the server that we're using an include. And then after this, we put in the actual include that we have. We tell it that it's going to be text, and then we give it an href for that text. And the href is an external entity, which is the file that we're trying to access. And when we do that, the server attempts to access that file. It returns back the text, which gives us this result here, which is very similar to before. So this should give you a general overview of all the different types of XXE-based attacks that you can do. There are more than just these four. However, these are the most common ones that I've typically seen throughout my experience. These type of attacks are very valuable to have because they are quite critical if they are found. And the ability to actually fix them can be fairly straightforward. There's a lot of different ways to do it. You can whitelist the inputs so that the user isn't able to input XML data into post data like this. For instance, we could check the product ID to see if it has XML characters and just blow it out if it does. In addition to this, typically most XML parsers that are modern will have some sort of way of safely parsing data now. So you can set specific flags inside of the parsers depending on your language to be able to say, don't do this, right? To be able to stop it from actually parsing it incorrectly. So those are the general ways that you can sort of mitigate the risk of these XXE-based vulnerabilities. Realistically, the best thing that you can do is not allow the person to directly input XML-based data. And typically, we might want to favor other types of data like JSON, for instance, that don't have these types of vulnerabilities associated with them. So those are a few different factors that you can consider with these. So that's the general idea of these XXE-based vulnerabilities, and you should now understand how to be able to find and exploit and hopefully fix these problems if you happen to find them inside of your own applications.